So this is our last section, which is to talk about acidic, basic, amphoteric, and neutral oxides. A compound named the oxide, that means it's actually a compound made out of an element and oxygen. So if I have sodium react with oxygen, I'll get sodium oxide. Then if I have carbon reacting with oxygen, I'll get carbon dioxide. I can also get carbon monoxide. So the whole point is just an element plus oxygen means it's a compound of, it's an oxide. So there are four types of oxides, which is basically the acidic oxide, basic oxide, amphoteric oxide, and neutral oxide. So according to the chart, you will see first elements are classified into metal and non-metal. So the metals will form basic oxides and amphoteric oxides. Then the non-metals will form acidic oxide and neutral oxides. This one is quite important to know. So then you have to go on and know the different characteristics of different oxides. So you know that non-metals may form acidic oxides. So these acidic oxides are usually gases at room temperature, and they will dissolve in water to form acidic solution. So for example, carbon dioxide reacts with water to form carbonic acid. So you will have an acid in the end. Acidic oxides, they will react with alkalis to form salt and water. So then becomes a bunch of equations again. So carbon dioxide plus sodium hydroxide will give you sodium carbonate and water. So this is just to tell you that acidic oxides, they react with bases and alkalis. So you have other acidic oxides, which is sulfur dioxide, sulfur trioxide, phosphoric 5 oxide. They are all non-metal oxides. Then you can have basic oxides. So metal oxides are called, metal oxides usually are basic oxides. So these basic oxides, they are solids at room temperature, and most of them are insoluble in water. So you can name sodium oxide, you can name potassium oxide, you can name calcium oxide. All these are all basic oxides. A few of them would, namely sodium oxide, potassium oxide, and calcium oxide, they will dissolve in water to form alkaline solutions. So you have an example here. They say calcium oxide plus water gives you calcium hydroxide. Basic oxide is the reverse of acidic oxide. So basic oxides, they react with acid to form salt and water. Acidic oxide, they react with bases to form salt and water. So then you have the chemical equation here. Calcium oxide plus hydrochloric acid give you calcium chloride and water. They might expect you to write this. Then the third type, which is the amphoteric oxides. Amphoteric oxides are also metal oxides. That they are a bit special because they react with both acid and bases to form salt and water. So for example, zinc oxide react with acid, we get zinc chloride and water here. Then it reacts with base to form salt and water again over here. Amphoteric oxides are easier to remember. So they are aluminum, lead, and zinc oxide. These three are the only amphoteric oxides that you need to know. Then you have the last type, which is the neutral oxides. So some non-metal oxides, they form oxides that show neither basic nor acidic property. That means they don't react with acid and they don't react with base. Then they are insoluble in water. And one characteristic to know is in a molecule of neutral oxides, there is always, almost all the time, only one oxygen. So you can have water, you can have carbon monoxide, you can have nitric oxide, all these are all neutral oxides. So they don't react with base, they don't react with acids. So the summary is here. And again, you can print it out for your own purpose, reference, etc. Now, this is a chart to show you how to determine the nature of the unknown oxide. That means to say you want to know whether the oxide you have on your hand is neutral, basic, amphoteric, or acidic. So what you first do is you take the oxide and then check if it's soluble in acid. If it's soluble in acid, that means it is actually a basic oxide or amphoteric oxide. If it's not, then it will become an acidic oxide or a neutral oxide, because acidic and neutral oxides don't react with acids. So once you get that, you will then decide whether it is soluble in alkalines, alkalis or not. So you come from this point here first. If it's soluble in alkalines and alkalis, that means it's an amphoteric oxide. If it's not, then it's a basic oxide. So same goes on the other side. If it is soluble in alkalis, then it's an acidic oxide. If not, it's totally neutral. This chart is a chart for reference only, because they won't ask you to regurgitate this chart. Instead, they will ask you to apply the information from here. Question 14. Which of the following can react with both acids and alkalis? That means it means they are looking for amphoteric oxide. So they're asking you which of these four options is an amphoteric oxide. So recall which oxides are amphoteric oxides. We can go back to this. You see amphoteric oxides. There are three of them down there: lead, aluminium, and zinc oxide. So then you go to here, pick your amphoteric oxide. Yes, like that. So the other two amphoteric oxides are zinc oxide and aluminium oxide. Okay, 15. Which of the following oxides causes the pH value of soils to drop below 7? So what kind of oxides are they looking for? Carbon monoxide is a neutral oxide, one oxygen only. So it's neutral. If it's neutral, it does not react with water to form acids. So A is not the answer. So acidic oxides are non-metal oxides. So you have to go to your options, pick the non-metal oxide. Yeah, that's the answer. We will let you fill in. Nitrogen dioxide has more than one oxygen. So it cannot be a neutral oxide, it must be acidic. So now we have another set of questions. You have to deduce whether they are, you have to deduce what kind of oxides are these four oxides based on the characteristics given by the question. Why is it an acidic oxide? What evidence show that it is an acidic oxide? If I were to ask you for an explanation, why is it an acidic oxide? Would you be able to produce the answer? You don't know. Okay, it first is it reacts with water. Okay, so the first evidence it reacts with water, and then when it reacts with water, it turns blue litmus paper red. This one tells you that the solution form is acidic solution. So A, crystalline solid that is able to react with water to produce an acidic solution must be an acidic oxide. It's because it reacts with water to produce a solution that's acidic. So that's why A is an acidic oxide. Part B. So you have another oxide. Okay, why is it an amphoteric oxide?
Because it forms a hydrogen solution when it is mixed with acid
and also sodium hydroxide.
and base.
Yeah, so the answer would be because it reacts with sodium hydroxide and hydrochloric acid. So it must be an amphoteric oxide. Correct. Next. Okay, correct. Because it has no reaction with both. Last one. Okay.